So today we're going to look at limits by substitution. So from the first video you watched on limits, we noticed the notation we're going to be dealing with now is the limit as x approaches some number of some function, f of x. All right? And in the last video, we would graph f of x and see what that graph is doing as it approaches a particular number. And we also use tables to identify the limit. Now today we're going to look at a little bit easier way of dealing with finding limits, and that is by substituting in. What I mean by that is whatever x is approaching, whatever number, we're going to take that number and just plug it in to the function and evaluate it. So, looking at the first one here, the limit as x approaches to a 4. The function 4 doesn't have an x in it, so I can't plug anything in. So for any problems like this, it's always just going to equal whatever the function is. The reasoning behind that, if you think about the graph of y equals 4, that is a horizontal line at y equals 4. So if we think about what is my graph doing when x is approaching the number 2, this graph is still just going to 4. Doesn't change. And just a quick example of another one of these. I mean, it could be anything. The limit as x approaches 57 of 104, right? The function is always approaching 104. It's never changing. Now, number 2 is the most basic substitution problem you'll see. So, the limit as x approaches 5 of x. I'm going to plug 5 in for x. So when I do that, I don't need to do any algebra because it's just going to be 5. Now let's get a little bit more complicated here. The limit as x approaches 3 of 2x squared minus 3x plus 4. So we're going to plug in 3 for x and solve. So 3 squared is 9 times 2 is 18. Negative 3 times 3 is negative 9. 18 minus 9 is 9 plus 4, so this limit equals 13. So as x approaches 3, for that particular function, the graph, or the y value it's approaching, is 13. Now, number 4 is where we're going to start looking at rational functions. And with rational functions for substitution, we always need to make sure that the denominator doesn't equal 0. Now, 95% of the problems that will have a fraction in it, when you plug in the x value, it's going to make the denominator 0. And we're going to have to utilize factoring or changing a complex fraction by multiplying the LCD through it, or rationalizing, because we'll have a square root in the denominator or something like that. So those are all tools we'll talk about in a second. But here's an example of one that does work right away. So if I check the denominator and I plug in negative 2, I would have negative 3 times negative 2, which is 6, plus 5 is 11. So I'm good to go. I can plug in because I know the denominator is not going to be 0. So negative 2 cubed plus 2 times negative 2 squared minus 1 minus 3 times negative 2. Negative 2 cubed is negative 8. Negative 2 squared is 4 times 2 is positive 8. And then we have 5 plus 6. So we have negative 1/11. And that's it. Now, number 5 is where we start looking at what happens when the denominator is 0. So plugging in 0 right away, that bottom is going to equal 0, and I can't have that. So when we have polynomials on top and bottom, we always want to try factoring first. That's usually the easiest thing to do. And in this case, I notice on top, it has a GCF of x, so I'm going to pull an x out of the numerator. Now, another important note to make here, until you actually substitute in that number, you have to keep writing the limit as x approaches 0. Like you have to, or the problem will be wrong. Okay, so make sure you always write the limit until you go to substitute. So, the limit as x approaches 0 of x, 5x squared plus 6, all over x. So I see I have an x on top and bottom, so I can cross those out. So my new limit So the limit as x approaches 0 of 5x squared plus 6. Now when I plug in 0, I don't have any issues. So we can go ahead and substitute. That would equal 0. So my answer would be 6. Now, looking at number 6, I know it's a little bit more complicated to see if the denominator is 0 here. If you want to just assume the denominators are going to be 0 and factor always, that's not a bad idea. Worst case scenario, you factor the denominator, nothing cancels, and it doesn't equal 0, so you're fine. But if you plug in negative 4 squared would be positive 16. 7 times negative 4 would be negative 28, so 16 minus 28 is negative 12, plus 12 gives me 0. So I need to factor out that denominator, because when I plug in negative 4, it makes the bottom 0. So we have the limit as x approaches negative 4, x plus 4 on top. Now on the bottom, I need factors of 12 that add up to 7. So that would give me 4 and 3. Now I see I have x plus 4 on top and bottom. That'll cancel out. So we have the limit as x approaches negative 4, 1 over x plus 3. Now I can substitute in. So that would give me negative 1 on the bottom. So I'd have 1 over negative 1, which is just negative 1. Okay. Number 7. Plugging in negative 2 right away makes the denominator 0, so I need to try factoring. I notice I have a perfect square minus a perfect square. So this is going to be difference of squares. So the numbers I'm going to use in my pattern are x and 2. So we have the limit as x approaches negative 2. On top we have x plus 2, x minus 2. Bottom we have x plus 2. So I see the x plus 2's will cancel. So we have the limit as x approaches negative 2 of x minus 2. And now I can substitute, which gives me negative 4. Alright, number 8. Plugging in 2 into the denominator, I get 4 plus 4 is 8, minus 8 is 0. So we need to factor. Now on top I have 4 terms, so that means I'm going to factor by a grouping. So we have the limit as x approaches 2. Looking at the first 2 terms, I can pull out an x squared. And that would leave me with x minus 2 inside. Looking at the last 2 terms, I can pull out a positive 1, leaving me with x minus 2. Remember, with factor by grouping, the inside parenthesis always has to be the same. Now on bottom, I need factors of negative 8 that add up to 2. That would be negative 4, or positive 4 and negative 2. Now we just need to finish factoring the top. So the limit as x approaches 2, x squared plus 1, x minus 2, all over x plus 4, x minus 2. X minus 2's will cancel. And I have the limit as x approaches 2 of x squared plus 1 on top, x plus 4 on the bottom. And now it's safe to substitute. I can plug that 2 in, no problem. So on top we would have 2 squared plus 1. On bottom, 2 plus 4. 2 squared is 4 plus 1 is 5. 2 plus 4 is 6. And there's my answer. So that's using factoring to kind of change how the problem looks so that we can plug in safely without having a denominator equals 0. Now we're going to look at dealing with complex fractions. Now here is my big fraction bar, and then I have 1, 2, 3, 4 pieces inside of that big fraction bar, right? 2 on top, 2 on bottom. Now when I plug 1 in, that's going to make the bottom of the big fraction bar 0. And I can't have that. So I want to find my least common denominator, my LCD. So I want to look at all the little pieces inside of the big fraction and pull out all those denominators. In this case, there's only one denominator, x. So for this problem, my LCD is just x. So we're going to multiply everything inside by x. So we have the limit as x approaches 1, 1 over x times x is 1. Negative 1 times x is negative x. X times x is x squared. Negative 1 times x is negative x. Still, plugging in 1 makes that bottom 0, so I'm not done. So I need to think about what I can factor. Now, if I think about the top here, rearranging it so it looks more like what we're used to seeing, x would be first. So this would be negative x plus 1. But we always want x to be positive, so I would factor out that negative 1. Okay, so the limit as x approaches 1 of negative x minus 1 on top. On bottom, I have a GCF of x. Now I see what cancels. X minus 1, x minus 1. So the limit as x approaches 1 of negative 1 over x, plugging in 1, give me an answer of negative 1. All right, number 10. Plugging in 0 obviously makes the denominator 0. So I want to find that LCD. So looking at all the little pieces inside of the big fraction, I see I have x plus 5 as a denominator. I see I have a 5. And the x on the bottom doesn't have a denominator. So my LCD is just 5x plus 5. So multiplying everything by 5x plus 5. 1 over x plus 5 times 5x plus 5. The x plus 5s would cancel. And I would be left with 5. Minus 1/5 times 5x plus 5. The 5s would cancel. And I'd be left with just the x plus 5. And then multiplying it to the denominator, nothing's going to cancel. So I would have the 5, the x that's already down there, and the x plus 5. Now the biggest mistake people will make here is they go, oh, I see an x plus 5 and an x plus 5. So these will cancel. You can't do that. And the reason you can't do that is because of this minus sign right there. Anytime there's a plus or a minus sign, we can't just go right into canceling things, okay? So what we're going to have to do instead is distribute. So we would have the limit as x approaches 0, 5 minus x minus 5, and I'm going to leave the bottom factored. So on top, the 5s would cancel. 5 minus 5 is 0. So we have the limit as x approaches 0, negative x over 5x, x plus 5. Now I see what will cancel and make this problem work. I can get rid of the x. So the limit as x approaches 0, negative 1 over 5x plus 5. Now I can plug in 0 with no problem. So we would have negative 1, 0 plus 5, negative 1. 5 times 5 would be 25. All right, so that's dealing with complex fractions. Now the last two problems, we're going to look at what happens when I have roots. So looking at number 11, the limit as x approaches 16 of x minus 16 over the square root of x minus 4. Plugging in 16 initially to the denominator, the square root of 16 would be 4 minus 4, which would give me 0. So I can't just substitute. But we can rationalize this thing to change it up. And we rationalize by multiplying by the conjugate. Conjugate is a term that people always forget. But remember, conjugate is just changing the sign in the middle. So I'm going to multiply top and bottom by the square root of x plus 4. Square root of x plus 4. So the limit as x approaches 16. Now on top, nothing's really going to cancel out. So I'm just going to leave it as those two factors, x minus 16, square root of x plus 4. Don't make yourself do more work by foiling that thing out, because you'd have a bunch of different numbers. Now on the bottom, we are going to FOIL that out. And if you recognize, this is the same pattern as difference of squares. So if you recognize the difference of squares pattern, we're just squaring the first term, squaring the last term with a minus sign in between. If you don't recognize that pattern, just go through and FOIL it. So I'll FOIL this one. Square root of x times square root of x would be x. square root of x times 4 plus 4 square root of x. Negative 4 times square root of x is minus 4 square root of x. And then negative 4 times 4, negative 16. So those two things would cancel out. We have the limit as x approaches 16, x minus 16, square root of x plus 4, all over x minus 16. Now, I don't have plus or minus signs in between my two parentheses. It's multiplying, so I can get rid of the x minus 16s. So the limit as x approaches 16, the square root of x plus 4. Now we can substitute. 4 plus 4 would be 8. Now, number 12, same type of problem, right? I plug in 9, that makes the bottom 0. So I need to change the problem up. Now, we can multiply the conjugate to move that to the bottom. So we're going to multiply top and bottom by the square root of x plus 3. Okay. So the limit as x approaches 9. Now I'm going to do this one with the difference of squares pattern. So square root of x squared would be x, always a minus sign. 3 squared would give me 9. Okay. Now again, if you don't recognize that pattern, you can FOIL it out yourself. On the bottom, nothing's going to happen. It's just going to be a mess if I try and FOIL that. So I'm going to leave it as x minus 9, square root of x plus 3. Now I see I have x minus 9s on top and bottom, so those will cancel out. So we have the limit as x approaches 9, 1 over the square root of x plus 3. Now we can substitute. 3 plus 3 would give me 6. And that's it.